Good day and welcome to the Math Hub. Today we want to look at this tutorial. It's a tutorial, and in it tinoda kupractice the quotient rule. Quotient rule inoshanda pakudifferentiate fractions. So that is what we want to do. We are going to be using example 1 and example 2 as our model questions. So let us start with number 1. Number 1 is good. If y is equal to x squared over 3x minus 1, find dy dx. Saka taudzwa kuti y iri equal to x squared over 3x minus 1. As I advise, it's better kuisa this expression 3x minus 1 in my brackets. We want to find dy dx. Saka before we find dy dx, firstly we take note. We want to differentiate a fraction. But we don't use the quotient rule always. Sometimes tinenge tine a fraction like this. Imagine a case yakati y is equal to x squared plus 4x over x. Of course that is a fraction, but we have an easier way of solving that, because itari express yakati y is equal to x squared over x plus 4x over x. Tichapesera tana y is equal to x plus 4, and we can easily differentiate y is equal to x plus 4. Saka mukashandisa quotient rule inobuda apo, but it's an overcomplication. Maths dzakadesigniwa kuti mushandise the easiest method available. Saka it's not always the case kuti ukangona fraction unototi quotient rule. Sometimes you are going to waste your energy and time muchiapply a quotient rule paisingafaniri kuapplyiwa. So the first thing you do, the first test, kutarisa like the fraction you are given, then you try to simplify the fraction in any way possible. Kana fraction yacho isingasimplifyiki, then you make the conclusion you want, or you actually have to use the quotient rule. So when we look at y is equal to x squared over 3x minus 1, there is no viable way of simplifying that. So to that end, tinofanirwa kushandisa the quotient rule. Quotient rule inoti kudini. If you forget, I'm sure irimo in your formula booklets. Quotient rule inoti dy dx, which is d of u over v dx is equal to, always start with the v, so it's v du dx minus u dv dx over v squared. That is what the quotient rule says. So that is basically what we are going to be doing. Saka chekutanga chatinoita tinoti let u be equal to x squared. Saka u should be the numerator all the time, v should be the denominator. But tinototi let u be equal to x squared, at the same time tinofangwa kubva tati what is du dx. Saka we just want to differentiate x squared, of course inotipa 2x, like that. Then tobva tati let v be 3x minus 1, and dv dx is going to be equal to the derivative of this 3x and 3, derivative of minus 1 is going to be 0, of course, because it's a constant. Having done that, let me katuwekere kuside kunoku, and let us also remove this to reduce clutter. Okay. Saka tava na u edu du dx, tina v dv dx, tova tati dy dx is equal to, start with v du dx minus, because the quotient rule, u dv dx over v squared. This is now a matter of substitution. V ndiani, v d bracket 3x minus 1 times du dx, which is 2x. And I always prefer to sign these boxed brackets in the event I must solve within bracket first, minus what is u into x squared multiplying dv dx, which is 3. This is over what? V squared. What is v? 3x minus 1 squared. Saka panapa takungoda kushandisa basic algebra to solve these things. Let us expand my brackets muno. 2x times 3x, that's 6x squared. 2x times minus 1 to minus 2x. And of course, minus times x squared into minus x squared times 3, minus 3x squared. This obviously is over bracket 3x minus 1 squared. Those who understand, those who know mathematics, kana tine anything in the denominator, don't be too quick to simplify it. And so this is equal to 6x squared minus 3x squared, the 3x squared. Of course, now minus 2x. This is equal to 3x minus 1 squared. Then of course we can simplify this. Take a factor out x pamsoro panapa. Tinosara tina 3x minus 2. This okay? And this is over 3x minus 1 squared. Saka practically panapa ndo panogumira our solution. Okay, so that is how we do example 1. Let us go on to do our example 2. Example 2 is kuti if y is equal to ln of x, I'm not ln, to far out ln, so y is equal to ln x over x squared. Find the value of dy dx when x is equal to e. So we want to find the value of dy dx, but taudzwa kuti x is equal to e. Saka pano we obviously have a fraction. We cannot simplify the fraction in any way. Mudzimini ngayakurasai kana ukatanga kudai so that's terribly wrong. You cannot do that. Saka hatina nzira yekukwanisa kusimplify our fraction. So what are we going to do rather? Use the quotient rule. Saka kuti tishandise quotient rule kutanga ni kuti chi? Let u be equal to ln x. U sorry equal to ln x. What is going to be du dx? Saka rangarira vana vaneanda kuti if y is equal to ln of ax plus b, and itika, what is going to be dy dx? Dy dx is going to be equal to 1 over ax plus b multiplying a. So this is what we call the general rule. General rule inotudza kuti kana chida kuwana the derivative of a natural logarithm, tichati 1 over ax plus b. But in mfunzo wangu unoramba uchitine makaye why, and why does it work like that? And that's real analysis, you can find it out. But for A level, pure maths especially, you are not required to know. You are not required to be able to derive these things. But if you want to develop your thinking mathematically, you have to always ask why. So why does it work like that? I don't have the answer yet. But differentiating a natural logarithm, it's 1 over ax plus b. Correct, 1 over whatever comes after ln multiplying a. VP. A is what they refer to as the inner derivative. Correct, derivative here bracket here. ra-ax plus b. So using the general rule zvoreva kuti kana tichidifferentiate ln of x tichati 1 over whatever comes after ln, which is x, multiplying the derivative of what comes after ln 1, kureva kuti this answer will be 1 over x. Zvakakosha kuziva kuti the derivative of ln x ndi 1 over x. Musina kana kutomboita first principles like that. Something you should know. Put it somewhere in your mind. Kuti the derivative of ln x is 1 over x. Very important. It will save you a lot of trouble. Okay. Now taziva kuti the derivative of u anenge ari 1 over x. Tenge takuzodzoka pano toti let v be equal to x squared, kureva kuti dv dx anenge ari 2x, like that. Okay. Now let us progress. Yeah, that's hopefully a straight line. So tavana u na du dx, tavana v na dv dx. We already know, let me remove this part. We already know kuti d of u over v, which is the derivative, dy dx, is equal to, always start with v. Why? You can Google it out. Du dx, subtract u dv dx over v squared. Simple substitution. What is v? V in the x squared multiplying du dx, which is 1 over x. This subtracts co-union ln x multiplying dv dx, which is 2x, like this. This is over, what is v? X squared, but it's v squared, so it's x squared squared. Okay, so this is equal to, simplifying, x uyanonopinda podai x times 1, that's x. Then panapa, please msaita mistake yekunyora makadai so. Kuti panapa ln x times 2x munoti, maybe your answer would be ln x 2x, kana kuti 2 ln x squared. Ameno. No. Your correct answer here is simply going to be minus 2x. Denotanga unyorwa tozoti ln x, like that. This is over. Of course, we can put this as x to the 4. Okay. Saka pano munogona kudai so, since we have a shared denominator, munogona kunyora makati x over x to the 4 minus 2x ln x over x to the 4. X panapa opinda x cubed, x uyu onocheka x cubed. Kureva kuti your final answer here is going to be 1 over x cubed subtracting 2 ln x over x cubed. X uyu na x cubed uyu asina ukama. Saka that would be your final answer. Ndataura with confidence kuti final answer, but I can never be more wrong because of the question. So maybe I should give you advice here. Whenever you are answering any question in mathematics, before you conclude kuti answer nayo is the final answer, just try to check. Go back to the question and see if you have actually answered the question. Saka question yedu tikadzokera kwa iri yabva yati, we have to find the derivative of this when x is equal to e. Saka teta kunyora kuti when x is equal to e, zvoreva kuti dy dx inenge iri equal to 1 over e cubed, like this. minus 2 ln of e over e cubed. Then chimwe chinhu chinongozikanwa kumedzi chandisingatogoni kutsanangura kuti chinobvepi, sekusagona kutsanangura kwandoita kuti 1 plus 1 is equals to 2, mofanira kungozivawo kuti ln e ndi 1. I cannot explain why, but that's it. Ndozvazviri. Saka pano inenge iri dy dx is equal to 1 over e to the 3 inowanzonyorwa iri e to the negative 3, then minus 2 times 1, since ln e are 1, e to the negative 3, like that. So this will be equal to e to the negative 3 minus 2e to the negative 3. Then mukachicherechedza e to the negative 3 minus 2e to the negative 3 zvangofanira kuti x minus 2x, kuroti answer yedu panapa inobuda iri minus e to the negative 3. Mukona kuwana amwe mabhuku achiti minus 1 over e to the 3, however ndo mabudiro angaita answer. So the lesson we derive here is always check if you have answered the question all the time. Always check, otherwise unogona kugumira panapa and be happy kuti ndawana all the 3 marks, when in actuality you can be given 1 if they are merciful that day, because unogona kuanswer the question. So this was the tutorial we wanted to conduct on the subject matter of quotient rule. If you enjoyed and learned something, good for you. Thank you and take care.